Hey, and welcome to MathWork. So today we'll look at how to inverse of a matrix using the characteristic equation. So my first step is to calculate, the characteristic polynomial. So how do we calculate the characteristic polynomial? So this is what we are going to use. We say the determinant, then this is just a scalar, lambda, multiplied by an identity matrix, which is a 3 by 3, minus the matrix itself. Okay, then you equate it to 0. The second step is to replace the inverse of the matrix in the polynomial and simplify. The third step is just to make the A inverse the subject of the formula. Okay, just making the subject of the formula, then we are well and good to find the inverse of a matrix. Okay. So we are supposed to find the characteristic polynomial. Now we are going to use, we use this one to calculate the characteristic polynomial. So in this case, we should get 0. So it will imply that the determinant so lambda multiplied by the identity matrix will get lambda 0, 0, 0, lambda 0, 0, 0, lambda minus the matrix A, which is this one. Okay, now we are told that this should be equal to 0, so it will imply that. So that's what we have there. So now we find the determinant of this matrix. Okay, so calculating the determinant of this matrix, we have here, okay, everything here should be equal to 0. Should be equal to 0. So we have that lambda minus 1 positive 2, we get a positive 2. Okay, then here what do we have, what do we get? So 0 plus this to be basically lambda minus 3. That's what we are going to get, lambda minus 3. So we have negative 2 multiplied by, so negative 2 multiplied by lambda, then this negative 2 multiplied by negative 3 get positive 6. So this should be equal to 0. Then simplifying this, we have, so there's a way that you can confirm that your characteristic is correct. In this case, you can get this matrix here, your matrix A. So you replace it where there is this lambda. Okay, where there is lambda, you put your matrix A. So following our instructions or our steps, we are told that we should replace the inverse of the matrix in the polynomial and simplify. So in this case, what we have in the polynomial, so let's put the matrix first itself. So our polynomial P of lambda is given by lambda cubed minus 13 lambda squared plus 31 lambda minus 17. Okay, so where there is lambda, we put A. So P of A, which is this matrix. Okay, so P of A, that's okay. So P of A, we have A cubed minus 13 A squared plus 31 A minus 17. So that's our characteristic polynomial. when we replace the matrix A in there. So if we are to solve, we are to replace the matrix here, we should get 0 when we solve, when we replace the matrix. So now we have found our characteristic polynomial, which we are told in this question that we should find the characteristic polynomial. So we are told to find the characteristic polynomial of this matrix, which is this, okay? So from there you earn marks. So now we are supposed to find its inverse, okay? Now we find the inverse of this matrix. So finding the inverse, we'll say, let's multiply this matrix by A inverse, okay? So we multiply this matrix by A inverse. So multiplying this matrix by A inverse, so A inverse. So our A inverse here is this one, okay? This is our A inverse. So we make it the subject. So making A the subject, it will imply that now, so multiplying the two, we get this as our A squared. So now we can put our A squared here, then we subtract 13 multiplied by the A minus 31 multiplied by the identity matrix, so we can solve that somewhere. So we can get, after simplifying this part, we have that this is what we get as our matrix. So therefore we can simplify this one. So our A inverse we equal to 1 over 17 multiplied by the matrix, this one. So 21, negative 3, negative 4, 2, 7, negative 2, minus 3, minus 2, and 3. So simplifying that, you can simplify, okay, you can just end here as your inverse, or if you want you can go further by writing as fractions, okay? So you have 21 over 17. This is another way of solving the inverse of a matrix using the characteristic polynomial. So thank you for watching. Enjoy your day.